Good.
All right, welcome. We're going to be doing Lab 9 for Physics 123, major section. This is the Michelson Interferometer lab, and here we actually do have a Michelson Interferometer. If we come to the back here, we can see that there is a laser beam here. It gets reflected off a couple mirrors, goes through some polarizers and a diffuser so that it's easier to see the fringes. Don't really need to worry about what's happening here. The most important part is the actual interferometer itself, where we have a half silvered mirror, which will cause half of the light to bounce off and go this way, and half of the light will pass through and then go this way. And so this is just one arm of the interferometer. It's just going to go through the air, bounce off this mirror, and come back. The other arm, there's this gas chamber, this black thing, which we're going to fill with different gases. You know, we're going to evacuate it so that it's just in a vacuum, and then we're going to fill it slowly with air and then with helium. And the difference in index of refraction of air and helium will cause a delay in this arm of the interferometer, and that's going to change, and that's going to cause fringes to appear, and we're going to interference pattern on the screen here as the light comes back and then goes out this way, interfering due to this delay introduced by the gas chamber. And so what we're going to go ahead and do is we're going to begin by measuring the length of the gas chamber so we know how long the light is going to go through the gas. And so we just have a pair of calipers, it's just in millimeters right now. So we're going to go ahead and measure the length here. All right, and so just record that number. That's going to be the L number, the length of the gas chamber. And it's going to be the same for both the air and the helium because we're using the same chamber. But that's pretty much all there is to the apparatus. Let's go ahead and get started. One thing that you'll notice is that we have a pressure sensor, a pressure gauge connected to the gas chamber. So right now it's at atmospheric pressure and it's reading here. So what we're going to do is we're going to turn on our vacuum pump. It's going to be a little bit loud, but we're going to see this come down as the pressure, as the air gets evacuated from the chamber, the pressure is going to drop, obviously. And we can see that. And we're going to go ahead and do this for about 2 to 3 minutes so we can get pretty close to vacuum in there. And we'll come back when we get down lower. Okay, and we are back. It has been a couple minutes, and as you can see, we're down to about a little over 10 millibars in pressure, which is pretty close to zero. We're not going to be able to get all the way to zero just because our vacuum pump isn't that strong, but we're good enough that it shouldn't affect our measurement too much. And so what we're going to go ahead and do is turn off the vacuum pump, and then if we come down to the screen here, we should be able to see our interference pattern. Okay, so here we can see our interference pattern, and so what you're going to want to note is how many fringes come into the screen here as they pass by as I release air slowly into the chamber. And so you may have to rewatch it if you don't get it the first time, but you just want to count those fringes as I begin to open up to air. So I'm going to go ahead and let air start to come in, and again watch those fringes closely and just count the ones that come into the screen. Okay, and now we're back to our room pressure, so it's filled with air, and that was the number of fringes that passed. So hopefully you counted them. If not, maybe you go back and count again to make sure you have a good number. But that is all you need to find the index of refraction of air. So you have the length and you have the number of fringes. I think that's capital N on your sheet, and we'll go ahead and empty out the chamber again, and then do it again except with helium. Okay, we have evacuated the chamber again, and we are close to a vacuum. This time we're going to be filling it with helium instead of air. So again, follow the same procedure as before and count the fringes as they come into the screen, but this time we're doing it for helium instead of air. Now I'm beginning to slowly let helium in. Try to be as steady as I can. Of course, it's not too practical, but you should be able to still see those lines move in. So you can tell there was a lot less of them just because the index of refraction of helium should be less than air. And so we saw less fringes. And now if you do the calculation, you should find index of refraction for helium. Again, it should be a little bit less than air. And then that should be all that you need for the lab. Good luck with your calculations, and don't be afraid to reach out to a TA for help if you do run into any difficulties.